Section 10. Database Normalization 1. Introduction. Database normalization or normalization is the process of organizing the columns, attributes, and tables relations of a relational database to minimize data redundancy. Normalization involves decomposing a table into less redundant and smaller tables without losing information, defining foreign keys in the old table referencing the primary keys of the new ones. The objective is to isolate data so that additions, deletions, and modifications of an attribute can be made in just one table and then propagated through the rest of the database using the defined foreign keys. You have learned from previous study session how to model data for database design. In this study session, you will learn database tables and normalization, the normal forms INF, 2NF, and 3NF, and how normal forms can be transformed from lower normal forms to higher normal forms. Learning outcomes. At the end of this study session, you should be able to 1. Explain database tables and normalization. 2. Discuss the normal forms 1NF, 2NF, and 3NF. 3. Explain how normal forms can be transformed from lower normal forms to higher normal forms. Database tables and normalization. Database table is a set of data elements, values, using a model of vertical columns, identifiable by name, and horizontal rows, the cell being the unit where a row and column intersect. A table has a specified number of columns but can have any number of rows. A table is a collection of related data held in a structured format within a database. It consists of fields, columns, and rows. In relational databases and flat file databases, a table is a set of data element values using a model of vertical columns identifiable by name and horizontal rows. The cell is being the unit where a row and column intersect. A table has a specified number of columns but can have any number of rows. Each row is identified by one or more values appearing in a particular column subset. The column subset which uniquely identifies a row is called the primary key. Database normalization. This is a technique of organizing the data in the database. Normalization is a systematic approach of decomposing tables to eliminate data redundancy and undesirable characteristics like insertion, update, and deletion anomalies. It is a multi-step process that puts data into tabular form by removing duplicated data from the relation tables. Normalization is used for mainly two purposes, namely 1. Eliminating redundant, useless data. 2. Ensuring data dependencies make sense, that is, data is logically stored. Normalization may have the effect of duplicating data within the database and often results in the creation of additional tables. While normalization tends to increase the duplication of data, it does not introduce redundancy, which is unnecessary duplication. Normalization is typically a refinement process after the initial exercise of identifying the data objects that should be in the database, identifying their relationships, and defining the tables required and the columns within each table. The normalization process. In normalizing databases, you should bear the following in mind. Each table represents a single subject. No data item will be unnecessarily stored in more than one table. All non-prime attributes in a table are dependent on the primary key. Each table is void of insertion, update, and deletion anomalies. The objective of normalization is to ensure that all tables are in at least 3NF. Higher forms are not likely to be encountered in business environment. Normalization works one relation at a time and progressively breaks a table into a new set of relations based on identified dependencies. To begin discussion on normalization, let's review the concept of functional dependence as summarized in Table 10.1. Concept: functional dependence. Definition: the attribute B is fully functionally dependent on the attribute A if each value of A determines one and only one value of B. Example: project number to project name, read as proj number, functionally determines proj name. In this case, the attribute proj number is known as the determinant attribute, and the attribute approach name is known as the dependent attribute. Concept: functional dependence. Generalized definition. Definition: attribute A determines attribute B, that is, B is functionally dependent on A if all of the rows in the table that agree in value for attribute A also agree in value for attribute B. Concept: fully functional dependence composite key. Definition: if attribute B is functionally dependent on a composite key A but not on any subset of that composite key, the attribute B is fully functionally dependent on A. Conversion to first normal form 1NF. Repeating groups exist if a group of multiple entries of same type can exist for any single key attribute occurrence. Relational tables must not contain repeating groups. Normalizing table structure will reduce data redundancies. Conversion to normalization is a three-step procedure. Eliminate the repeating groups. Eliminate nulls by ensuring each repeating group attribute contains an appropriate data value. Identify the primary key. The primary key must uniquely identify attribute value. Identify all dependencies. Dependencies are depicted with a diagram. After conversion to 1NF, the database in Figure 10.1 will now look like in Figure 10.2. The dependency diagram depicts all dependencies found within given table structure and helps in getting bird's eye view of all relationships among tables attributes. The dependency diagram for the table is shown in Figure 10.3. Summarily, 1NF describes a tabular format in which all key attributes are defined. There are no repeating groups in the table and all attributes are dependent on primary key. All relational tables satisfy 1NF requirements because this would have been achieved at the ER modeling stage. Conversion to second normal form 2NF. Make new tables to eliminate partial dependencies. Partial dependency is a situation with which attributes in the table depend on a part of the primary key. Write each component on a separate line and then write the original composite key on the last line. Each component will become a key in the new table. Assign corresponding dependent attributes. Determine attributes that are dependent on other attributes. At this point, most anomalies have been eliminated. A table is in second normal form 2NF when it is in 1NF and it includes no partial dependencies. The dependency diagram for the 2NF is shown in Figure 10.4. The normal forms 1NF, 2NF, and 3NF. The normal forms defined in relational database theory represent guidelines for record design. The guidelines corresponding to first through fifth normal forms are presented in terms that do not require an understanding of relational theory. The design guidelines are meaningful even if a relational database system is not used. The guideline is present without referring to the concepts of the relational model in order to emphasize their generality and to make them easier to understand. Since data which may have been retrievable from one record in an unnormalized design may have to be retrieved from several records in the normalized form, there is no obligation to fully normalize all records when actual performance requirements are taken into account. There are several stages of normalization called normal forms. There are basic three normal forms, which are first normal form 1NF, second normal form 2NF, third normal form 3NF. 2NF is better than 1NF, while 3NF is better than 2NF. For most business database design purposes, 3NF is as high as needed in normalization. The highest level of normalization is not always most desirable. First normal form. First normal form deals with the shape of a record type. Under first normal form, all occurrences of a record type must contain the same number of fields. First normal form excludes variable repeating fields and groups. This is not so much a design guideline as a matter of definition. Relational database theory does not deal with records having a variable number of fields. Second and third normal forms. Second and third normal forms, 2, 3 in bracket, deal with the relationship between non-key and key fields. Under second and third normal forms, a non-key field must provide a fact about the key, the whole key, and nothing but the key. In addition, the record must satisfy first normal form. We deal now only with single-valued farts. A single-valued fart could be a one-to-many relationship such as the department of an employee, or a one-to-one relationship such as the spouse of an employee. Thus, the phrase Y is a fart about X signifies a one-to-one or one-to-many relationship between Y and X. In the general case, Y might consist of one or more fields, and so might X. In the following example, quantity is a fart about the combination of part and warehouse. Second normal form. Second normal form is violated when a non-key field is a fart about a subset of a key. It is only relevant when the key is composite, that is, consists of several fields. Consider the following inventory record: part, warehouse, quantity, warehouse address, key. The key here consists of the part and warehouse fields together, but warehouse address is a fart about the warehouse alone. The basic problems with this design are: the warehouse address is repeated in every record that refers to a part stored in that warehouse. If the address of the warehouse changes, every record referring to a part stored in that warehouse must be updated. Because of the redundancy, the data might become inconsistent with different records showing different addresses for the same warehouse. If at some point in time there are no parts stored in the warehouse, there may be no record in which to keep the warehouse's address. To satisfy second normal form, the record shown above should be decomposed into replaced by the two records: part, warehouse, quantity, key, warehouse, warehouse address, key. When a data design is changed in this way, that is, replacing unnormalized records with normalized records, the process is referred to as normalization. The term normalization is sometimes used relative to a particular normal form. Thus, a set of records may be normalized with respect to second normal form, but not with respect to third. The normalized design enhances the integrity of the data by minimizing redundancy and inconsistency, but at some possible performance cost for certain retrieval applications. Consider an application that wants the addresses of all warehouses stocking a certain part. In the unnormalized form, the application searches one record type. With the normalized design, the application has to search two record types and connect the appropriate peers. Third normal form. Third normal form is violated when a non-key field is a fart about another non-key field, as in employee, department, location, key. The employee field is the key. If each department is located in one place, then the location field is a fart about the department in addition to being a fart about the employee. The problems with this design are the same as those caused by violations of second normal form. The department's location is repeated in the record of every employee assigned to that department. If the location of the department changes, every such record must be updated. Because of the redundancy, the data might become inconsistent, e.g., different records showing different locations for the same department. If a department has no employees, there may be no record in which to keep the department's location. To satisfy third normal form, the record shown above should be decomposed into the two records: employee, department, department location. To summarize, a record is in second and third normal forms if every field is either part of the key or provides a single valued fact about exactly the whole key and nothing else. Denormalization. This produces a lower normal form and increases performance but causes greater data redundancy. Let's consider an example of a company that manages building projects and charges its clients by billing hours spent on each contract. Hourly billing rate is dependent on an employee's position. Periodically, report is generated that contains information such as displayed in Table 10.1. One may be tempted to think that the database should be represented as shown in Figure 10.1. However, You will observe from the database table in figure 10.1 that it does not handle data very well. The table structure appears to work because it facilitates report generation. However, the report may yield different results depending on what data anomaly has occurred. Summary. As we conclude this study session 10, you are expected to have learned that 1. Normalization reduces data redundancy. 2. There are 3 levels of normalization that are realistic: 1NF, 2NF, and 3NF. Other forms are 4NF and BCNF, Boy's Code Normal Form. 3. In 1NF, repeating groups are removed and primary keys identified. 4. In 2NF, the table is in 1NF and partial dependencies are removed. This is the end of study section 10. Thanks for listening.